Okay, students, this is an economics crash course to prepare you for your midterm covering chapters 1 through 6 of N. Gregory Mankiw's Principles of Microeconomics. Now, chapter 1, we're not covering all that much. He's got his 10 different principles of economics, but we're going to focus mostly on chapter 2 and some of the other things within chapter 1. So the big concepts that we're covering are scarcity, opportunity cost, trade-offs, 4 factors of production, division of labor, specialization, 3 basic economic questions, production possibilities curves, increasing versus constant opportunity costs, per unit opportunity cost, productive efficiency, allocative efficiency, and positive versus normative statements. All right, so let's get a laser pointer going here. There we go. Scarcity. So scarcity is universal. It exists in rich countries, poor countries, and it's a combination of having limited resources, which is true of all countries, but also unlimited wants makes scarcity always present. And because you have limited resources and you're trying to fulfill your wants or your needs, you have to make choices for how you will fulfill your wants or needs. That is what leads us to opportunity costs. Opportunity costs are when you're looking at a list of choices and you choose one, your next best option, or what you could have had if you didn't make that choice, is your opportunity cost. So a definition could be your second best option, what you lose when you make a choice, or some economists like to say an opportunity cost is an opportunity lost. And this could be quantified. If you have a trade-off, which is giving up some of something to have some more of something else, like more bathtubs for fewer barrels, and you choose to produce more bathtubs, let's say you go from point A to point B, you could look at exactly how many barrels you had to lose, and that would be your opportunity cost, whereas the general trade-off is more bathtubs for less barrels or more barrels for fewer bathtubs. Okay, 4 factors of production. These are the things that make things. They are land, labor, capital, and entrepreneurship, or natural resources, human resources, capital resources, and entrepreneurship. An example of a natural resource would be paper for a paper chain factory. The human resource would be the people that are working, that are cutting the paper, assembling it, whatnot, assemblers, cutters, tapers, workers. And then the scissors would be a capital resource because it's something that you use when you're producing the good, but it's not a part of the end product. And then the entrepreneurship we see within that activity, and that people are talking and planning how they're going to put together the paper chain and which jobs people are going to have. That's entrepreneurship, deciding where your other factors of production should go or what they are going to be doing. Okay, division of labor is taking a big task like making a birdhouse and breaking down into smaller tasks like woodcutter, gluer, and painter. Right, so it goes that direction, taking a big complicated thing, focusing it on small tasks, and then when workers focus on those small tasks and do them over and over, that leads to a faster rate of specialization, which is workers focusing on a task and getting better at it quickly. Okay, and then the 3 basic economic questions that every economy needs to answer is, what are we going to produce, how are we going to produce, and for whom to produce? We're not going to focus on this a whole lot, but different countries have different ways of answering those questions in terms of what to produce, what kinds of things are we going to focus on? Right? For some countries, it might be the basic necessities for everybody. Others, it might be trying to create things that people are willing to pay or that people really enjoy. And the type of economic system determines how these questions will be answered. How to produce, is the government going to produce it, are entrepreneurs going to produce, and then for whom to produce, who gets to make that choice, and who gets things, what's the allocation of these resources, is really what question 3 gets at. Okay, the production possibilities for curve. First graph that we're seeing, we have guns and butter. We've got some made up numbers. The main things that you should know is anywhere inside the curve is inefficient, on the curve is efficient, and beyond the curve is impossible at this time. Another thing is per unit opportunity cost, which is your units lost versus your units gained. So let's answer a per unit opportunity cost here pretty quickly. Let's go from A to C. So at point A, I have 30 guns, right, and 5 butter, and I'm getting more butter when I go to C. My gain is 5 butters, so 5 butters my units gained, but then in order to get those 5 butters, I have to lose 10 guns, and so my loss is 10 guns, and so for each butter, right, I am losing 2 guns. So 10 guns over 5 butter, my units gained, means that I lose 2 guns for each butter that I gain along here. So the whole jump is how much 5 butters is, but if we want to see how much each step, each butter would be, I would be losing 2 guns for each one of those steps along. Okay, and that plays into constant versus increasing opportunity costs. And a constant opportunity cost production possibilities curve is going to be flat, and as you can see here, as I increase by 5 each time, my opportunity cost is 10. So my per unit opportunity cost is still the same as this example, 2, but I'm losing 10 with each one of those large jumps. But the main thing is the jumps are the same and the loss is the same every time. Versus increasing opportunity costs, as I increase by 5 units over here, I end up losing 2 units. But then my next step of increasing 5 units, I lose more units. I lose 7. And then my next step, I lose a whole lot. I lose 21. And so increasing opportunity costs, the more you produce of either good, the greater and greater your opportunity cost is going to be with each additional step. Now, the reason why we have constant opportunity costs sometimes and increasing opportunity costs is for constant opportunity costs, your resources are the exact same. It takes the exact same workers, ovens, and natural resources to make a pizza versus a calzone. And so if I'm going to make one more calzone, I have to give up those natural resources, the time of the workers, the oven time, in order to make that calzone rather than making a pizza. Versus increasing opportunity costs, your resources are very different. And because your resources are different, you use what is most efficient to produce that other good first. And so your loss isn't that much, but then the more and more you produce of that good, the more you have to use resources that aren't readily adaptable to make it. Okay, again, productive is on the curve, right? So anywhere on the curve would be productively efficient. A is efficient, C is efficient. If there's something all the way on the axis here, that'd be efficient. If there's something all the way here, that would be efficient. But allocative efficiency is really producing the right amount of things for society. The production possibilities curve doesn't tell you that. You have to know the demands of society in order to pick the correct point, which would be allocatively efficient. Okay, positive statements are any statements that are a fact claim. They can be refuted with data, and data alone is another way to think about it, and they describe the world as it is. So, um, um, the value of a dollar decreases when the money supply increases. That would be a positive statement, right? A normative statement describes how the world should be. Generally, it's an opinion, or it is an opinion, and it describes how the world should be. And you can't use data alone to determine whether or not it is false. You can still argue about it, but the data alone doesn't give you that factual answer. So we should print less money would be a normative statement because I'm describing something that should happen based on my opinion. All right, now we're moving on to chapter 3. A lot fewer terms here, but you really have to be able to do these comparative advantage problems or you're going to be up creek without a paddle. Okay, absolute advantage is the country that can produce the most technically with the same amount of resources as the other country, or the country that can produce something using the least amount of resources. Yeah. Okay, so um, that's absolute advantage. Who can make the most is how you can think of it, though. Comparative advantage is the country that has the comparatively lower opportunity cost. And this is going to, if you have two countries trading with one another, each country will have a competitive advantage every time in one of the goods that we're talking about. The 5 steps I use to solve a trade problem are square absolute advantage, find the opportunity cost or per unit opportunity cost technically. You do the bubble 7, which I'll talk about, star what you should specialize in, and then find your exports and imports. The bubble 7 is really useful for trade range as well. And then gains from trade just means how countries the amount that countries can consume beyond their own production possibilities curve that result by trading with one another. All right, so here's an example problem. Desks, computers. First thing I'm going to do is I'm going to square absolute advantage. South Korea can make more desks. South Korea can make more computers. And then I'm going to find my opportunity cost. So what I do that is take the other and I put it over. So I take 20 and I put it over 10 when I'm looking at my production of desks here. So for each desk I make, I'm giving up 2 computers if I'm the United States, right? And then I can just flip it. I can find the reciprocal over here. So each computer for the United States is going to cost 1/2 of a desk. I can take 10, other, put it over here, 20, and that gives me 1/2 of a desk. Down here for South Korea, one desk is going to cost 40 over 30 or 4/3 of a computer. And then over here, one computer is going to cost 30 over 40 or 3/4 of a desk. Now I'm going to do my bubble 7. It's just a shape. I drew it like that. And then I'm going to star what I should specialize in. So the bubble 7 helps me look at my opportunity costs and determine who's got the lower opportunity cost. South Korea does for desks. So I'm going to put a star right here. And then the United States does for computers. 1/2 is less than 3/4. So I'm going to put a star right here. And you're going to export whatever you specialize in because you're making that thing, so you're going to export it to the other country. And then you're going to import whatever you have a higher opportunity cost in. So I'm going to import desks if I'm the United States. I'm going to import computers if I am South Korea. And then if you're asked to trade range, really it's a good trade as long as it's between the 2 numbers in your bubble 7, right? So another thing I would say is if you're asked something like, is 1 desk for 3 computers a good trade? Find the first thing that is in terms of 1, and then just focus on that column. So desks, 1 desk for 3 computers. Is it a good trade? And then you might have to say, is it a good trade for who? All right. So it would be a good trade for South Korea because they're selling computers and they would want a high price for that desk, right? It costs them 4/3 of a computer to make a desk. So if they can get 3 computers from the United States and sell them 1 desk, they're quite profitable. They're profiting 1 3/4 of a computer. Okay, now if you're the United States, though, you're not going to make that trade because you can make it yourself for 2 computers. So that's a bad trade for the US, so the trade would not happen. Okay, moving on, chapter 4. There's a lot in chapter 4 because it's supply and demand. That's what everybody remembers about economics. Willingness to pay to a small extent. The law of demand, price and quantity, income effect, substitution effect, diminishing marginal utility, the determinants of demand, normal versus inferior goods, law of supply, profit motive, determinants of supply, equilibrium, price and quantity, shifting curves and finding new pricing quantity, and the double shifters and what indeterminate means. So firstly, willingness to pay is the maximum that consumer would be willing to pay for a good or service. This is what the demand curve is made up of. Now, the demand curve goes down and to the right, and the reason why it does that is because individuals don't want to purchase as much if the price is high, and if the price goes down, they want to purchase more. This is called the law of demand. As price increases, quantity decreases. As price decreases, quantity increases. There's an inverse relationship. Now, the reason why, I don't have that here. Anyway, the reason why the law of demand exists, I do, sorry, is because of the income effect, substitution effect, and the law of diminishing marginal utility. The income effect is that as the price of something goes up, you can buy less of it, so it's like your income or your purchasing power decreased, or I could flip that and say the same thing as long as I change the signs of what I just said. The substitution effect is that as the price of something goes up, I could purchase something else instead, or if the price went down, I might purchase less of that other good, so I can enter or exit that market. That's the substitution effect and how much I can do that. And then the law of diminishing marginal utility, you can think of it this way. You don't like something as much the more and more you consume of it. And so as quantity goes up, the price that you're willing to pay goes down. So that's another factor for why the law of demand exists or why the demand curve slopes down and to the right. Okay, and then price and quantity is what the demand curve is made up of. I can't really describe so much, just keep in mind that price is on the y-axis, quantity is on the x-axis. Okay, the determinants of demand. These are things that would actually shift the curve. So if you're changing price, you're just moving along the curve. But if these things change, now people think of that product or service differently. And if these change, the demand curve would move either to the right, showing an increase, or to the left, showing a decrease. So consumer tastes and preferences, if that changes, people think something's trendy, more demand, it moves to the right. Or if it's unfashionable, less demand. Income, generally, more income, more demand, less income, less demand. Market size, if there are more people to buy something through advertising or other means by which people become aware of a product, more demand. Market size gets smaller, less demand. Right? And then price of related goods. This one's kind of interesting. For a substitute, let's say the price of, let's just take something we know as a substitute like Coke and Pepsi. If I go to the store, maybe I don't care about one or the other, at least the market in general thinks that they're substitutes, and the price of Coca-Cola has gone down because it's on sale, I am going to be less likely to buy Pepsi. So the quantity demanded of Pepsi decreases as the price of Coca-Cola decreased. So substitutes, price goes up, the quantity of the other good also goes up, price goes down, the quantity that people would want of the other good would also go down, or the demand, we'll say. Because it really is a change in the demand. I think of Pepsi differently now because the comparative good, Coca-Cola, is cheaper or more expensive. And that will change my willingness and ability to buy Pepsi at every single price. Okay, complements. Milk and cereal. If the price of milk goes up, I'm less likely to buy cereal, so demand will go down. If the price of milk goes down, maybe I go, oh, milk's really cheap. I might buy more cereal, so my demand would go up. So complements, the price of one good and the demand of the other good do opposite things. But it's a lot easier rather than think of those relationships and what the signs are doing to just think, what would I do if I'm in the store and this happens, this change in the price of a good happens, and I know that this good is a substitute or a complement. Okay, and then consumer expectations is generally about price. If I think that the price of gasoline will be lower in a week, I'm less likely to purchase gasoline now. I'm going to drive it on fumes until I can buy it at a lower price. Or you can think of Black Friday. Nobody's buying a brand new TV a week before Black Friday. Okay. Normal versus inferior goods. Normally, as your income goes up, your demand for a good goes up, but there are inferior goods, such as off-brand goods or used clothing or used cars or whatever, where if your income decreases, you have more demand for these things. Or let's say you make more money, your income goes up, you might not buy as much of these things, so you have less demand for them. Okay, and then moving on to supply. The law of supply is as price goes up, quantity goes up, or as price goes down, quantity goes up. There's a positive or direct relationship. And the reason why that happens is because when the price of something goes up, entrepreneurs or businesses want to produce more of that thing because they are chasing the profits. So the supply curve goes up and to the right because of the profit motive. It's also a cost curve, but I won't get into that right now. Okay, determinants of supply. Price or availability of resources. So if something is more scarce and it's used to make a product, you can supply less of that product. Technology, generally you can produce more at each price. So increase in technology shifts the supply curve to the right. More competition or more producers shifts the curve to the right as well. Price of related goods now is not substitutes or complements, but it's instead more like the production possibilities curve. If I'm Bic and I could produce razors or pens, and now I can make a lot more money by producing pens, I'm going to move on my production possibilities curve more towards making pens rather than making razors, because I'm making more money with those pens. And so I'm going to increase that production and then decrease the production of my razors. So the price of related good there would be, I'm just moving up and along the supply curve for, I think pens is what I'm getting a better deal for, and then my supply of razors is decreasing. Hopefully I didn't flip that around. And then government tools. Taxes and regulations are both going to decrease supply, because that's when the government takes money or adds more rules, which would increase the costs because you're using more time from your employees to make sure you're following the regulation. And then subsidy would be increasing supply because the government's giving you money to do something that's going to incentivize you to do it. And then producer expectation is generally, do we think that something will eventually be profitable or catch on or be worth investing in so that we can have a market later? Like producing a streaming service because you think that eventually it will become very profitable. All right, equilibrium, price and quantity. This is simply where supply and demand cross, and where supply and demand cross, quantity supplied ends up being equal to quantity demanded. Okay, shifting curves. These are the only four things that could happen with single shifts, and then these are the only four things that could happen with a double shift. So, first, single shifters. If supply is shifting, it can either increase by moving to the right, or it can decrease by moving to the left. Make sure that you're not thinking up or down, because if you think supply is going up and you move it like this, you've actually decreased supply. So that's where you have to be careful and know that an increase is a rightward movement, and a decrease is a leftward movement. Now, if supply increases, we see that price goes down, quantity goes up. We see the law of demand happening because we're now moving along the demand curve, and quantity demanded is changing in response to that change in supply. If supply decreases, price goes up and quantity goes down as we move along the demand curve with that decrease in supply. Demand. If demand increases, we see the law of supply, because now the price and quantity are both going up as we move up and along the supply curve. And if demand decreases, now we see price and quantity fall because we're moving down and along the supply curve. And your determinants of supply and demand are the only reasons why these curves would shift. Okay, double shifters. So, for double shifters, either price or quantity will be indeterminate. And what that word means is we can't really determine whether or not it's gone up or down. Now I'm going to switch to a pen here quick to try to show this. Let's say in this scenario, supply and demand are both increasing. It looks like the price is the same as it was, and it for sure looks like quantity increased. Now, I'm going to say price is indeterminate here and quantity increased, and the reason is I don't actually know which one moved more. I just know that they both increase based on that type of problem. But let's say supply moves a little bit more than we drew it. In that case, price would decrease. But, here we go. But if demand moved more than we thought, and let's say this is D2, and forget that this demand exists, then price would increase. So it depends on which one's moving, it depends on their elasticities, and we can't really know. And so that's why when it looks like they're fighting and it looks like it's in the same spot, we have to say that it is indeterminate. So supply and demand both increase, price is indeterminate, quantity is increasing. Supply and demand both decrease, price is still indeterminate, and quantity is decreasing. And now when they're fighting each other, when demand goes to the right but supply decreases, price skyrockets and quantity is indeterminate. But now when supply increases and demand decreases, price falls precipitously and quantity is indeterminate. All right, chapter 5, elasticity. Not a lot of vocab, but a lot of math that is kind of scary at first. The main reason is we have difficulty separating the percent change formula and fitting this, because if we look here, the percent change formula is used for everything, right? This, you can pick your one. We're either using the standard method, which is looking at new minus old divided by old. You don't really have to multiply by 100% on both sides, and you'll still get the same coefficient because you're doing this to a numerator and denominator. It kind of cancels out, but that's technically when we say a percent change is by multiplying by the percent. Or midpoint, in which you do new minus old divided by the midpoint. And if you can't do the midpoint in your head, you can just add new plus old and divide by 2, and that will give you the midpoint. So let's say that we're going from 8 to 10. My new would be 10, my old would be 8, so I'd have 2 as the numerator. And then my midpoint Maybe I don't know the difference between, or the in between 10 and 8, it's 9, but if I add 10 plus 8, I get 18, divided by 2, I get 9. So that's another way to do it if the numbers are a little bit more mean than that. Okay, this type of formula, or this formula, whichever one you're using, standard midpoint, is that component, percent change, percent change, percent change, percent change, percent change, percent change. So you use this every time you're finding the numerator up here and every time you're finding the denominator down there. Now, one nice thing is all of these other formulas, all of these other formulas have, let's get back to my laser pointer, quantity on top, right? It's a slightly different kind of quantity each time, but if you're given that problem, you know the numerator is quantity every time, so you probably shouldn't get too lost. So here, price elasticity of demand and price elasticity of supply, they're pretty much the same formula, okay? It's percent change of quantity divided by percent change of price. The only caveat is demand would technically always be negative because it's a negative slope, but we just drop that negative sign, and so we kind of get the same thing. And the coefficient interpretation is the same as well. If something is 1 for demand elasticity, we'd say that it's unit elastic. We might say the same thing for supply. I guess I'm not really sure if that crosses over, but if something is less than 1, we say that it's inelastic for both demand and supply elasticity. And if the coefficient is greater than 1, we say that it is elastic. And a really high elasticity number for demand reveals that that type of good is a luxury. Okay. Cross price elasticity. This is the same as what we did with demand with substitutes and complements, but now we're finding the actual math. And it doesn't matter which good is good A, which good is good B, but all we're doing is we're finding the percent change of quantity of the good that we're studying. So if I was looking at orange cross price elasticity to apples, the oranges would be the quantity change that I'm looking for. The apples would be the price change. Okay, but I'll try to be nice and only give you the prices that you need. But anyway, I look at the quantity percent change of oranges, and then I look at the percent change in the price of apples. And if I had a positive sign, which I likely would, right? The quantity of oranges went up when the price of apples went up, I would have substitutes. But if I had, say, milk on the top here and cereal, let's say the price of cereal goes up, my quantity of milk might decrease. And so since this one is negative and this one is positive, I would have a negative coefficient here, and that would tell me that they are complements. Okay, now down here, income elasticity, you're just finding percent change of income and percent change of the quantity of something. But this will tell you whether or not you have negative goods or inferior goods. Okay, if your income went up, that would be a positive sign, and your quantity went down, that'd be a negative sign. That would tell you that you have inferior goods. You're buying less of something with more money. Or if you buy more of something with less money, that would also have one negative symbol either in your denominator. So that would tell you that this is an inferior good. But if they're both positive or they're both negative, then you would have an example of a normal good. Okay, chapter 6. This one goes quick. We have price floors and ceilings, binding and non-binding, price floors and ceiling, shortages, surpluses, and tax incidents. So, price floor, price ceiling. This is a binding price floor. The floor keeps something from falling any lower from where it wants to go. So if I take my pen and my arm is a floor and I drop it, my arm keeps it from falling any further. Where prices want to go is equilibrium, right here. But prices can't go to equilibrium because a floor is a legal minimum set in place by the government. And so whenever the government sets a binding price floor, it's going to keep the quantity demanded back here because the price is higher, people don't want as much, but producers are going to try to chase those profits. The quantity supplied will be way out here, and anytime the quantity supplied is greater than the quantity demanded, it's going to cause a surplus. A price ceiling, a binding price ceiling, keeps the price from going up where it wants to go. And the only time it's going to be binding is when the price ceiling is below equilibrium because prices will want to go to equilibrium. But the price ceiling is a government maximum on a price, and that's going to keep the quantity supplied here because producers aren't making as much of a profit. They don't want to supply quite as much. And then consumers want a whole lot of that cheap good, but they're only going to get this much, and so that's going to put you into a shortage. They want more at a lower price, but they can't get as much as they want because the quantity demanded is greater than the quantity supplied. If the price ceiling were up here, we'd say that it's not doing anything because it's non-binding, and if the price floor below equilibrium, we'd say it's not doing anything because it's non-binding. Okay, tax incidence. We are going to hit this one again later, but right now we'll just look at it. It's just how much of the tax falls on the buyer or the seller. And you're going to have greater tax incidence for whichever curve is more inelastic. So here's an example of inelastic demand. This is my equilibrium price and quantity. Demand is a little steeper. And the big thing with tax incidence is you're going to take that tax wedge, all right, we'll take it this pen, and it's going to be the height of the tax. So here for the inelastic demand one, I know that the tax is $4, and I'm just imagine that with me for right now. So you're going to take that $4 on the graph, and you're going to move it until you end up getting it wedged between your two curves. And so as we do that, we move it horizontally and we wedge it, we see that it hits the demand curve right here, and we have $6, and here we have $2 on the supply curve. The difference between the two is the height, or the amount of the tax, which is $4. And that shows us what our new quantity will be. It shows us the price that buyers have to pay as a result of a tax, and it tells us the price that sellers, or the amount that sellers get to keep after paying the tax for a product. Okay, with that, you determine the incidence based on how much the seller gets to keep and how much the buyer has to pay as compared to when there was not a tax. So prior to the tax, the equilibrium price was $3. After the $4 tax, the buyer now has to pay $6 and the seller only gets to keep $2. So the buyer in this case ends up paying a greater percentage of the tax because the demand curve is more inelastic. That's the math behind it, but determining that tax wedge is really what you want to do. Okay, inelastic supply, now the supply curve is more inelastic, and if I take a $3 tax and I move it to the right and I wedge it, okay, that ends up giving me a price that buyers are going to pay of $4 and the price that sellers get to keep of $1. So now in this case, since my old equilibrium was $3, sellers are keeping $2 less for every unit sold, and buyers are paying $1 more for every single unit. So more of this tax is falling on the seller because their supply is comparatively more inelastic. Okay, and that's everything. Hopefully that helps. Good luck.